Here we are in Unit 1, Activity 8, Question 1. Notice there are 5 bullet points, so please account for those when you're answering your question. So the first question is, what is the equation of your movable line? So once you've set up your graph to include the x-axis as beats per minute before exercising, and the y-axis is beats per minute after exercising, and then you created your residual, or excuse me, your line of best fit. By clicking on that line of best fit, we're given an equation. I don't want you to copy my equation. I want you to simply have whatever equation you found by moving this line around and getting what you think would be the best line to represent the trend of this data. So I'll go ahead and leave mine here. So mine is I'll put 3.7. I'm going to go ahead and round that 6 up to 7 based on this, times x plus 33. So I'll come over here, and again I want you to do a different one than what I did, and I don't think 47 is the right y-intercept number, so that plus 33. Okay, so what is the slope? The slope is the number that is right in front of the x, so the coefficient of x. So in this case, my answer would be, in IMS is the letter that's used for slope. I imagine that comes from the word mountain, or montagno. Montere is the word for slope in Old Latin. So the slope for my equation is 1.37. The y-intercept, intercept for me is 33, and the question, is it meaningful? And I'm going to say it is not meaningful. Why? Why is a pulse of 33 not meaningful? And again, the way I can figure that out is that if this trend were to go down, 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 and it would eventually hit here at y equals 33. Well, why is that not a meaningful number? Why is there known with a pulse of just basic 33 here in this? So that's what you're going to put there in part C. Now part D, it says look at point 7436. The original wording was a little bit different, but I went ahead and isolated one variable. So we come here, and here's 7436. So that's a pretty good one. So I'm going to take 74, that you can see it showing up here, and I'm going to plug that 74 right here into this x, and I want to see what I'm going to get. So I'm going to come up here, and so I'm going to take my original equation, and I'm going to come down here, I'm going to paste it in, and instead of x, I'm going to go ahead and I'm going to type in 74. So now I'm curious when I do this math, so 1.37 times 74 plus 33, does it give me 136? And I don't know, I'm going to just have to calculate that. So let's go ahead and get out my calculator here. So here's a calculator. Let me move it over so you can see what I'm doing. So if I do 1.37, my slope, times the beats per minute before exercise, 74, I get 101. Okay, and now I'm going to add the y-intercept, or the 33 points, and I got 134.38. And in actuality, the person's pulse rate after exercising was 136 beats per minute, but our model showed us 134.38. Now, for my question to you is, how far off is the prediction? Do you think that this model that I've identified here is pretty good at predicting the post-exercise pulse? Or do you think the model isn't? And so that's going to be up to you. But again, when you turn in your work, I want to see your formula, not my formula here. Let's try this again. So again, I don't want you to just randomly choose a point. I'm going to go ahead and get one. So let's pull one that's pretty far off. I'm going to choose this one here. So 58 and 140 it looks like here. So I'm going to come over here, and I'm going to put, look at point 58, 140. Let's make sure that's correct still. Yeah, 58,140 is correct. And so now what I'm going to do is I'm going to take my formula here, my regression model. I'm going to paste it down, but this time I'm not going to put in 74, I'm going to put in 58. I still will add 33. I'm curious if this gets me pretty close to 140. So let's bring this down here, and I'm going to clear everything out, and so I'll do 1.37 times 58. Remember, 58 was the beats per minute, the average beats per minute before exercising, and then I'm going to add 33 to that. So I got 112. So the regression model calculates 112.46, but their actual post-exercise pulse rate was 140 beats per minute. So I want you to explain what after exercise pulse rate does your line predict for the person whose data point you identified. So again, you're going to use this data point, but you're not going to use my formula, you're going to use the formula that you came up with up here. And then the next question I want you to answer is, how far off is the prediction? So remember, I calculated 112.46 with my regression model, but I know for a fact that their pre-exercise pulse rate was 58 beats per minute on average, and their post-exercise, so after exercising, average beats per minute was 140. So I have a pretty clear idea of how effective it was for people who aren't very close to the model.